Good day and welcome back. In this video, we are going to talk about uniform circular motion. I'm going to talk about a few important variables in circular motion and especially about the existence of centripetal force that cause the object to rotate along a circular path. Let's observe about this circular motion with a radius r. Circular motion happens when the object moves along the circumference of a circular path. One important observation is that the direction of motion is changing continuously, unlike in the case of linear motion. The change in direction can be described as the angular displacement, which measured in radian. So the magnitude of the velocity, which is also known as linear speed or the tangential speed, can be either uniform or non-uniform, which determines the angular velocity. Let's consider the case of uniform velocity for today's video, where we also describe this motion as uniform circular motion. Remember that velocity is a vector quantity. For uniform circular motion, although the magnitude of velocity is constant, but the direction is changing. Hence, we have another variable to explain about the change in direction, which is called angular velocity, which defined as the rate of change of angular displacement. It has the same symbol as the angular frequency, omega, as it can be also described as the rate of rotation of the object. As omega is equal to 2 pi f, the frequency here is referring to the number of revolutions of object per second. In other words, if the angular frequency or the angular velocity is 2 pi radian per second, the object is moving at 1 revolution per second. And then we also have the period t, which is the reciprocal of frequency, defined as the time taken for one complete revolution. Now we're going to find the relationship between the linear velocity and angular velocity. We consider a very short angular displacement that the linear displacement of object is almost the same as arc length of the circular path, s equal to r theta. So from here, we can determine the linear velocity is r theta divided by time, and then we can obtain the v is equal to r omega. Next, we're going to talk about acceleration. The linear acceleration of object in uniform circular motion is 0. However, since there is change in direction of velocity, we have another variable called centripetal acceleration in this case. To obtain centripetal acceleration, we need to get the difference between final velocity and the initial velocity, delta v. From the diagram here, we can draw the triangle solution and obtain the change in velocity by vector subtraction v2 minus v1. From here, the direction of change in velocity is actually toward the center of circular path. If we draw a triangle of a very small angular displacement, the change in v on top of circular path here is downward, which is to the center. And then based on similar triangle we can observe in this diagram, the red and purple triangle, we can build ratio equation here and obtain delta v is equal to v theta. Next is to divide both sides with time, and here we can obtain centripetal acceleration a is equal to v omega. So here the formula of a can be further derived by the equation of v equal to r omega. We shall have three formulas for centripetal acceleration, which are v omega, r omega squared, and v squared over r. And then one last variable to be discussed is about the centripetal force. As what we have learned about resultant force and also Newton's laws of motion, a moving object will continue to move in a constant velocity if there is no external force. But the word constant includes the magnitude and the direction of object. For circular motion, direction of motion is keep changing, so there must be a resultant force which is known as the centripetal force. Based on the formula of centripetal acceleration and also F equal to ma, we can quickly obtain the formula of centripetal force is mv omega, mr omega squared, or mv squared over r. Now, let's see one past year question in 2019. A circular deck of radius 10 meters is rotating above the water surface to make one complete cycle in 1 minute. From here, we are given with the information about the period is 1 minute or 60 seconds. We will go through all the variables that we have learned today. First is the frequency that is reciprocal of period, and it is 1 over 60 revolution per second, or in short, RPS. Next is the angular frequency, or also the angular velocity. We can use the formula 2 pi f, and it is equal to 0.105 radian per second. Then is the linear velocity, which is equal to r omega, equal to 1.05 meter per second. Next is the centripetal acceleration, v squared over r, and it is equal to 0.11 meter per second squared. So here, please don't confuse that the linear velocity of object is constant. The centripetal acceleration is reflected to the change in direction of velocity, which contribute to the circular motion. Lastly is the centripetal force, F is equal to ma, and it is equal to 7.67 Newton. So remember, there must be a force which is the cause of circular motion, and it is toward the center of circular path. Here, E will be the frictional force between the deck and the man X who is standing on it. Without the friction, the man will slip and drop into the water when the deck is rotating. Next, we're going to look at past year in 2015. Here, the surface is not a horizontal surface, but sloped at a certain angle to the horizontal surface. Here, you will need to resolve the related forces into two components. Vertically, we could see mg plus f sin theta is equal to n cos theta. While horizontally, where we have the resultant force, the centripetal force is equal to the sum of horizontal components of friction and the reaction force, n sin theta plus f cos theta. For this type of motion, it is the reaction force and the friction which provide the force to cause the object to move in a circular motion. So now, let's see some more examples. A similar case as previous question is found in the trial paper of SMKTK in 2022. The ball in the ball able to move in a horizontal circle is due to the reaction force on the ball. Here you can imagine it or you can run some experiment on your own. The linear velocity of the ball is the key parameter so that the ball can move in a horizontal circle. However, if the velocity of the ball is less than the required value, which is due to the friction that opposes its motion in the real world, the radius of circular path will reduce and the ball will slowly approach to the center. So this is what will happen if you conduct the experiment. In conclusion, the ball must maintain its linear velocity in order to maintain the circular motion. Another question is from the trial paper of SMKTK in 2022. We have an aircraft to fly in a horizontal circle. The centripetal force here is provided by the horizontal components of X, which is also the lift force of aircraft. For the car drivers on land, you can change the direction of the car simply by steering the wheel, but for the pilot to change the direction of aircraft, it is actually contributed by the lift force. So you may try those questions if you're interested. They can be found in the STPM Physics Telegram channel, which I have put the link in the description below. One last example is the tension of string that can provide the centripetal force for the circular motion. Here the tension in the string is provided by the weight of object Q. So the tension in the string is equal to 19.6 Newton. Now, we will focus on object P. Vertically, the weight of object P is supported by the vertical components of tension in string, where we have the equation of T cos 60 equal to the weight of P. Hence, we can determine the mass of P is equal to 1 kg. Then, we can also determine the centripetal force which is provided by the horizontal component of tension T. It is T sin 60 equal to 17 Newton. So in conclusion, circular motion can be understood as forces not in equilibrium. There must be a force that causes the change in direction of velocity, which gives us the angular velocity and centripetal acceleration. Before we end, let's explore further about this motion. The length of string is given, so we can calculate the radius of circular path is equal to 0.5 sin 60 degree equal to 0.43 meter. Well, we are going to move backward to determine all the values of angular variable. First is the centripetal acceleration, which is 17 meter per second squared. Then we can find the linear velocity is 2.7 meter per second, angular velocity is 6.29 radian per second, and lastly are the frequency and the period, 1 RPS and 1 second respectively. So that's conclude my discussion today. If you still have any question, leave it in the comment section below. Also, do leave a like and subscribe to my channel. I will see you in my next video. Thank you.